It's actually a two-part talk. I'm going to talk a little bit about a network operations side to this, but then hand over to David from Exa Networks, who's going to talk about the sort of software system side, which is where all of this sort of bug, I guess, sort of started. This all came about because I've been doing some work at Exa, helping out some stuff on their network operations team. And, well, one morning, there was a plethora of calls of the very, very vague and frustrating variety. The internet's not working. It wasn't affecting all customers. We initially thought in the networks team, we thought we've heard about some problems, some leased line backhaul, congestion issues. Maybe it's not that, because damn, it's now starting to happen on a couple of DSL customers, but the leased line customers are okay now. What's going on here? It was a problem that was very intermittent, but it didn't stop happening when we looked at it. It wasn't quite a Heisenbug. It manifested as a timeout loading web pages, and the only thing initially we could see that was in common was that this all affected customers using Exa Networks filtering service, which they provide to schools. So at this point, the network operations team was thinking, brilliant, it's not the network, which is quite a nice place to be, apart from the fact that the phones keep ringing. We decided, and David will explain the rationale behind why a bit more, to go and try and put some probe devices within customer networks. What we wanted to be able to do is see the problem that they were seeing from their vantage point. So we needed to make some sort of a probe device, a bit like a, I don't know, RIPE Atlas probe or something. We didn't want the customers to have to open up ports on firewalls, because that involves dealing with usually school IT managers and saying, could you please, and that's never a good place to be. So we needed something that would pierce NAT. Sorry, NAT. Security would have to be vital. We didn't want this probe to then be able to be an attack vector onto the customer's network for all sorts of reasons, like maybe GDPR. And we also needed a team of staff, both networks, systems, and whoever else, to try and figure out what on earth was going on with this bug. So this got me thinking to a few talks that I've been to in the time leading up to this problem. And so I'm going to give shout-outs to the people who gave those talks. 3 of these talks were at Net Manchester, which is an amazing event that Tom, and now Lou run in Manchester once a month. And back in Net Manchester 11, Tim Bray, who's talking here today about something completely different, had a load of questions, most open-ended, about IoT security. And in some ways, making this probe, it's sort of an IoT device. It's a thing that's going to go and live in somebody's network, is going to phone home, and hopefully is not going to become a botnet. So that was one talk that sort of influenced how are we going to do this. Net Manchester 13, Tim Fletcher gave a talk about doing SSH, but rather than with keys, with certificates. So, quick show of hands. Who uses SSH with keys and with a certificate authority? Why do so few of you use a certificate authority? Is it because it's hard, or is it because I don't need to? Well, Tim Fletcher's talk gave a very good intro into how one might and why one might use SSHCAs. And this is going to come back very, very shortly. Tim Panton gave a talk about how to do IoT security and NAT piercing and cool stuff with WebRTC and so on at Net Manchester 17. I think the URL pi.pe will actually tell you a bit more about that. And then finally, I attended a talk that AQL put on at an IoT roundtable in Leeds, which was actually all about how the RIPE Atlas probe was built and engineered from a security perspective. And actually, the RIPE Atlas probe, well, the name is a sort of good link, but also it's not a bad model for what we were going to try and build. We wanted to make something we could plug into a customer network, a school broadband link or something, and it would just magically get an address and it would connect back to some sort of Bastion host. Now, I'm going to do another quick show of hands. For management access, who uses VPNs? Who uses jump hosts or Bastion hosts? That's interesting, it's about 50-50, okay. The great thing about what we wanted to do here, and the way that RIPE Atlas work, is they both end up creating an SSH tunnel back to some centralized box. There's some telemetry and setup stuff that goes on with RIPE, and you can read about it in their presentation, which actually they gave at UKNOF some years ago. And the general feeling is RIPE Atlas has quite a good security rep. Some people have tried breaking it and going, yeah, it seems pretty good. So that, coupled with SSH certificate authorities, which Facebook, Netflix and others are using, that started to form the pattern that we're going to use for our little IoT probe project. Why Teleport? Well, we came across Teleport, which is an open source with enterprise add-ons SSH server, which is an SSH CA out of the box. It does two-factor authentication out of the box, so if you want to do two-factor, you don't need to install some Google Authenticator PAM module and risk locking yourself out of the box that way. There is a nice through-the-web SSH client, so you don't even actually need some extra client, though your normal OpenSSH SSH command line tool will work too. There's a callback to the GDPR talk about, one of the themes in GDPR is about organizational technical measures, and there's a bit about auditing. Teleport can actually record a session, the actual interactive session that happens, and it can, in more recent versions, do that for a legacy SSH session as well. So when you're jumping through Teleport to somewhere else, you can actually have a log stored of what actually happened during that session. There is a free open source, download it from GitHub with some binaries if you want edition. It's written in Go, you can compile it as well. There's a newish software as a service pricing model. We didn't need that for this project, and maybe if we had a need for role-based access control, the enterprise paid edition would have been of interest, but for what we need just a jump host and, well, in our instance, a few Raspberry Pis. So we deployed a Teleport VM for a Bastion host. We wrote an Ansible script, because we're all about automation, aren't we, these days, and a bunch of Raspberry Pis, and shipped those off to the customers and waited to see them connect back, which they did within a couple of days, and that was brilliant, because the software team could now do what they needed to do. How does Teleport work? Well, there's sort of 3 and a bit parts to it. There's the main 3 parts it talks about on the server side are a node proxy and an auth agent, and you log in via a client. And most people can just use it as everything runs in one process. But you could, for example, farm off the Bastion side to a separate front-facing node, and then have your entire cloud cluster of VMs or whatever behind that. And that actually was the original use case, I think, Gravitational wrote Teleport for, which was a Bastion host with a shed ton of VMs in AWS or the like, sat behind it. You can then separate out the auth to sit on a separate node and then do clever things with role-based access control and whatever. You can go crazy with high availability and load balancing. The sort of background AWS nature of this sticks out with its DynamoDB, sort of native functionality. But the way we wanted to use it was with a node being a trusting cluster in its parlance, which basically means that trusting node connects out to the Teleport Bastion, which basically means it jumps over a natting firewall, so long as it can make a connection out. How do you use it? Well, this is your equivalent of SSH key minus A. You log into a node with a specific user. It then asks for a password, two-factor authentication code, and you have now got a key, which is valid for a certain amount of time. Or alternatively, you could go to the web page on that Bastion host, bang in exactly the same details, and 2 clicks later you're logged in as root on some node that doesn't actually have internet connectivity itself, or you don't have direct internet connectivity to. As I mentioned, there is this ability to record sessions, which is basically like Twitch for terminals. I'm starting to see quite a few people using this in their network operations centers, where This is great for, do you trust all of your juniors with everything, or do you want to cooperatively work with your juniors on something they've not done before? So the first time, as they're trying to build up their skills, you literally can have two people working at one terminal, and then afterwards they can play it back in their own time, review what they did, what they learned, and you can then check if there was a fat finger incident by them later on. That very roughly is an introduction to Teleport. How it then got used with these Raspberry Pis out in a bunch of schools at Exa Networks customers, I'm going to now hand over to David to do the next half of the talk. So, thank you. David.
Hi everyone. I'm David Farrar from Exa Networks. As Marek mentioned there, I'll be talking about the motivations about why we needed this teleport host, and also giving some thoughts about my experience from actually using this as a user of teleport. So the actual motivation we had was we had a new monitoring system. It was actually something that replaced an existing solution we had people already using. So it wasn't new, but people were starting to need new features. Mostly web is becoming HTTPS based, and we didn't have the capability to filter what we were previously able to filter. I think, or I know, we've actually presented here about the previous version of the proxy. It was called Exa Proxy, and we basically rewrote the entire thing in Go, meaning that we had a system that's completely not battle tested. Obviously, we had lots of monitoring, lots of metrics that we were gathering about the new system, and for the next week after releasing it, we were carefully watching, getting increasingly happy that everything was working fine, until the call started. And at this point, the calls were saying, when are you going to fix these problems? We're all tired of waiting for you to fix the problems. Please make it work. The actual problem we had was we'd seen nothing about this before. Our monitoring showed no signs of issues, as I said. There was definitely nothing wrong with the network. And we realized that you can't plan for everything. We'd planned to try and cover everything we could, and assumed that we would miss something, which is why we moved to Teleport to fill in the gaps of what we hadn't previously looked at. So Teleport was great. It let us go and, with the knowledge that we'd missed something, start building a new system that would track the things we'd not been thinking of before. What we knew at that point was we had heavy traffic from the affected schools, but they were the only affected schools, and it was only people who were using an explicit proxy. So one of the capabilities we have was Active Directory integration. People wanted to be able to see who a user was and have custom filtering. And we, again, had this, we were testing exactly the same environment, and we didn't see a single problem. The assumption we had at that point was it was maybe the customer's firewall, and that it was a connection tracking issue, but we had no way to prove it. So once we'd shipped out these teleport devices, we started building as quickly as we could a monitoring solution that would act as a network probe. We realized very quickly that quick doesn't have to mean bad. And while we're used to building software that does exactly what we want, which involves lots of planning, making sure we've got the single source of authority for data, making sure we're distributed, making sure we can handle load, that wasn't anything that we actually cared about now. We just wanted something that worked quick, but we wanted something that worked quick and we didn't have to debug and put through testing because we were testing this system now anyway. For that, we decided to use as many open source tools as we can get our hands on that would replicate the actual customer environment and stick them together with Bash. The one technical choice that was pushed on us was we wanted to be able to glue everything together with Bash. So while we normally use Prometheus as a time series database, after we'd collected our data that told us what the state of the system was, how everything was behaving, we needed to be able to log it. And we actually went to InfluxDB for this because we knew that with a single HTTP request that was human readable, we could pipe that essentially into a new process using Bash and not have to do any of the work ourselves on custom software. Everything was stuck together with cron because all we needed was something that would run every minute. This is essentially the entire probe that we had. So very, very simple. We grabbed a time, so something that we can print in the logs and find on our logging to correlate what we're seeing. Just used curl to actually go and grab something because we were told that people's web traffic was timing out. Got the status code in case there was an issue that we were somehow missing in our monitoring. Measured the latency. That latency would be covered as well if there was no network activity. And then just bundled that into a single metric that we could write onto the type service DB. Because it was the SSO process, we also found that we would have to integrate with the user's environment. As Marek mentioned previously, we didn't have the most cooperative customers. At this point, we didn't know it, but they'd been suffering already for a week. They just wanted us to fix it. In keeping with the theme, we went for the nearest analog that we could to SSO, which was just to have a default Kerberos server that we were authenticating against. That lets us basically replicate exactly what the client would be doing anyway. We didn't have to build any fancy Windows SSO integration. I said I would give a mention of my experience using Teleport. Everything was nice and easy. We were able to SSH through the Bastion, get straight into the host, and then it came to actually deploying this, and we realized that Ansible was not aware of how to use Teleport. It turns out there's a really neat trick we could use with SSH. So by giving a proxy command actually encoded in the host configuration, we're able to make it look like we're just SSHing straight through to the probe without having to even think about the Bastion. We've used that since for setting up tunnels as well. So if you need an easy way of being able to browse from the school, from your local web browser, it's easy enough just to set up an SSH tunnel. At that point, we had absolutely no problems that we could find still, so it's time for plan B. The motivation for this, we said, is for all this work we've done, is we didn't know what the problem was. We had to ship something out or build this probe. We didn't know what we were looking for, and still we'd not found it. So it's time to move on to being more manual, just trying anything that we could to try and replicate the problem. One thing we did was use Apache Benchmark, which is a tool that's normally used for checking web performance. We were able with this to replicate having lots of machines opening lots of connections at once. And at that point, we finally started to see the issue. So in the data that we were gathering on Prometheus, we were graphing that, and we could see latency spikes or some connections that just weren't opening at all. TCP dump came to the rescue. We took captures on both sides of the conversation. At this point, we were still thinking it must be the customer's firewall, it must be a connection tracking issue, and we were expecting just to see missing sins on our side, but at least we could replicate it to find them now. What we actually saw, though, was the sins were coming through. They appeared to be part of an existing network connection, and we were seeing really, really skewy sequence numbers on them. So a little bit of head scratching, a little bit of making sure we understood exactly what the TCP state machine looked like. We found a great blog from Vincent Bernard that covers exactly what we should have expected. And we found that the TCP time wait setting was the most likely culprit here. So what we were seeing, normally this exists, once a connection is closed, there's an expectation that we may, because TCP is built to have reliable transmission on an unreliable network, the TCP time wait exists to keep a connection open a little bit after it's actually been closed by both sides, so that if there's any data that was part of the conversation before that point, you don't lose it. What we found is the particular, there were two different vendors with firewalls at the sites we were looking at. They had performed what we're calling an optimization, or we actually consider it to be a bug, where they're advertising headline speeds, or great headline speeds, lots of throughput on the firewall. That's based on having lots of connections, lots of machines talking through there, and having clearing off the connection tracking, clearing off the time wait so that the ports are still available for the next connection to come through. There's no waiting, and that's how they get the headline results. In our case, though, we weren't passing traffic to lots of IPs on the internet. People were using a single configured Active Directory proxy, meaning that every connection had to go to a single endpoint. There, we found that people were very quickly filling up the 65,000 connections that the firewall would normally have. The moment that the time wait was reached, those connections were able to be cleared from the firewall, and they started reusing ports that, because we were RFC compliant on our side, we saw the connections still being open. So because everyone's going to the same destination IP, same destination port, same source port, we only had that source port to work to identify the connection. Once we'd found that, it was easy enough to clear the problem just by changing the value on the vendor's firewall. What we actually did was find a solution that fits everyone. We didn't quite change that to match the value that we've got on our servers. Instead, we set that to something suitably high that we weren't seeing the problem anymore, but we also weren't getting problems for other services that weren't all coming through to us, and they wanted that same behavior. Other fun that we've used this teleport probe to fix as well, mainly involve Google. So I said before, we were able to create TCP or create tunnels through to the school and browse as if we were on site. The past few weeks, we've seen an increase in people reporting to us, again, that not just the internet's not working, but Google's not working, we keep being given a capture, or Google's not working at all. We found, since we're running an IP6 capable proxy, but we have IP4 only clients, we found that Google has been redirecting people to an IP6 only host, which is ipv6.google.com, as part of that capture process. So we were able to kill two birds with one stone by fixing the capture issue, but we wouldn't have necessarily seen, because we have IP6 connectivity where we're testing from, we wouldn't necessarily have seen what the problem was if we hadn't been able to browse from inside the network. It turns out Google's caused a few problems, so if there's anyone here from Google who'd like to talk, that would be great. But essentially, every problem we found since then, we don't know what it is yet, but we found that the teleport hosts running give us a really, really easy way of trying to think of whatever we can that's new to do it.
Do we have any questions? Everyone's out-of-band infrastructure's tickety-boo then. Yes.
Cool. Thank you.
Thanks, guys.
Thank you very much.